let's say this is slope for one side, and here we have slope for another side. You can say S2, and let's say this is just the width or breadth, okay? And here we have the depth, very simple. Now, if the depth is not known, there can be actually, let's say this is formation level, and here, as you can see, this is NSL. So one of, I mean, these two must be then known, okay, NSL. Then if these two are known, we can just subtract the NSL from the formation level. Like you can say formation level minus NSL, and this is actually the depth then, okay? So this is how you can calculate the depth. Okay, it is just, you can say, the difference of levels. Now, once we have the depth and then the side slopes, then actually what we do, we just split the same section into, you can say, different geometries such as this one, okay? And we call the central one is the area of the center, which is actually what? And it is just BD, because this is just rectangle. So we have the breadth and then the depth. Now, area of the sides, these are actually triangles. So area of this side should be SD square divided by 2, and this is actually S1. And for this side, area should be S2 D square divided by 2. It means the total area of the same section should be actually area, and it is BD plus S1D square divided by 2 plus S2D square divided by 2. Now, there is another thing. If S1 is equal to S2, then we can just simplify this thing a little bit more, okay? And this can be then, of course, area. If these two, if S1 is just S2, then area can be actually BD plus SD square only. So these are the formulas which may required, okay, and which may be needed, okay, in the calculation of cutting fill.